So as we have discussed, manually handling singleton class is not a solution. Let's look at some of the ways by which we could implement singleton. So here is one of the simplest implementation of singleton. So we need to basically follow 3 steps to implement a singleton class. So first of all, we have to add a private static field for storing the singleton instance. So here we have a private static final variable named as instance of type eager init singleton class, and we are initializing it here. Next step is to make the constructor as private. So this is to make sure that we cannot call constructor from outside. And then the third step is to declare a public static creation method for getting this singleton object back. So in this method, we are simply returning the instance field. So in short, we have to follow these 3 steps. So the first step is to add a private static field to the class for storing the singleton instance. Second step is to make the constructor of the class private so that it's not possible to access it outside the class. The third step is to declare a public static creation method for getting the singleton instance. There are different approaches in creating a singleton class. So here are a few approaches which we use in Java to create a singleton class. The first method is eager initialization. In eager initialization, the instance of singleton class is created at the time of class loading. This is the easiest method to create a singleton class, but it has a drawback that the instance is created even though client application might not be using it. So here is a class which uses the eager initialization method. So in this case, as we have discussed, there are 3 steps. The first step is to initialize the object of this class. Second step is to make the constructor of the class as private. And the third step is to create a public method which will return the instance or the object of this class. So as the name says, it's eagerly initialized. So that means the instance of the singleton class is created at the time of class loading itself. So the drawback of this method is that even if there is no client which is using this object, still the object exists in the memory, because whenever this class is loaded, the object of this class is created. So next we have lazy initialization. So as the name implies, lazy initialization initializes the object lately, only when it's really accessed. The lazy initialization method to implement this singleton pattern creates the instance of the class in the global public access method. Here is an example of lazy initialized singleton class. So as we could see here, the instance variable is declared here, but it's not initialized. So that means when this class is loaded, it simply creates this variable, but it doesn't initialize it. So where is this getting initialized? So as we could see, it is getting initialized within the public method. So within this public getInstance method, it's checking whether this instance is null, then it creates a new instance. If this is not null, then it will simply return the current instance. So as in case of the eager initialization method, the constructor is private, which means it can be accessed only within this class. So we are using this constructor inside the getInstance public method, and here we create the object of this class. The lazy initialized singleton method is comparatively better than the eager initialization singleton method in terms of performance, because in case of lazy initialization method, the instance of this class is only created when we call the getInstance method. So the object of this class is not created when this class is loaded. Instead, it is created when this getInstance method is called. In case of eager initialization singleton method, it was initialized when this class was getting created, right? So in that way, the lazy initialization singleton method is slightly better than eager initialization singleton method. But there is a big problem with this class. So this class is perfectly fine when your application is a single-threaded application. But in case if you have a multi-threaded application, this class is going to fail or create problems. Because since we are initializing this class within the getInstance method, there is a chance that each of the threads in your application might call the getInstance method at the same time, and each of the threads may get an instance or an object of this class, a separate instance or a separate object of this class. In case if the threads get into this if block at the same time, then each of those threads will receive an object of this class. So that will make this class as a non-singleton. So that's a problem with this method. So we have another method which will avoid that. We'll have a look at that shortly.